Okay, we're going to start now. And today we have a guest speaker, Kim Kline from ABVI, which I can't remember what it stands for, but he'll probably tell you. He's going to take the whole class period to talk about his experiences in accessibility. Take it away.
Okay. Well, basically, I want to start off by giving you a little bit of an introduction on who I am and what I do. My role is the role of Adaptive Technology Administrator. It basically means that I adapt computer systems and phone systems in our agency for people who are blind or visually impaired, and probably at some point in time some other disabilities will come into play also, but we haven't had that come up yet. So I do some development and also actually some troubleshooting when things go awry. The discussion here primarily is going to focus on computer technology, although certainly accessibility covers a lot of areas besides computer technology. For example, home appliances, things like communications equipment. All of those things can have accessibility barriers, and probably in a perfect world, somebody should be taking those things into account. My area of expertise is primarily in the Windows arena, although the things I'm going to say today would be applicable to, at least in some fashion, to the Mac world as well as other operating systems. I want to start off by defining a couple of terms. The first being accessibility and the second being usability. I think accessibility is a term that gets thrown around a lot and people kind of have an idea of what it is. Usability is probably somewhat less known. Accessibility really involves whether you can get to the information. So it doesn't necessarily take into account how many steps you have to take to get there. And so what we run into as people in the blindness world is sometimes you'll get something that somebody will say, well, that's accessible. And yes, it is, but you have to go through a lot of hoops to get the information, and it takes you much longer than everybody else. So usability, on the other hand, says that, well, not only is a thing accessible, but can you get to it with an equivalent amount of information, or an equivalent amount of effort to somebody who is not working with a disability. I can give you a case in point. A number of years ago, we looked at a package for a call center that was taking a contract for New York State, basically handling reports of injuries on the job with the state. And when New York State put the proposal for the contract out, they had said that their software was accessible. And I looked at it, and it actually was. Everything that was on there could be read with a screen reader. But the problem was, when somebody was taking one of these calls, you had a little like a little magnifying glass that you had to click on, which they had nicely tagged so that the screen reader read it and you could hit enter on it and it would open as if you had clicked on the magnifying glass. But then it had this very long list of different types of injuries that was probably 1,000 things in that list. And somebody with a mouse would just take the mouse wheel and just whip down through it until they saw what they wanted and then click on it. With a screen reader, you had to use the down arrow to go down through the list, and it read every single item. So what was happening was that people who were sighted could handle one of those calls in about 2 minutes. For somebody that was blind, because they had this big, long, cumbersome control, it'd take about 20 minutes per call. Needless to say, blind people did not get to work on that contract. That's an issue where it was accessible but not usable. Okay. Okay, I want to talk about some of the concerns for people who are blind versus people who have low vision. For people who have low vision, the typical barriers that you run into are things with poor contrast, things that don't magnify well, and there's a couple things that can come into play with magnification. One is whether the image, when you magnify it, whether it retains its shape and proportion. This is particularly a problem with zooming. And whether the print is in such a format that it's easy for somebody to read. Typically, for somebody with low vision, print styles that have a lot of serifs, like the little curly tails, those kinds of things, present a real problem for somebody with low vision. And so if you have the latitude of picking the print style, usually a fairly simple print style like Arial works best because it magnifies well, it's not hard to read, it's not complicated, and you don't have the little curly tails that can sometimes be difficult for somebody with low vision to read. And also, the characters are of a uniform thickness. If somebody has low vision, if part of the character is thinner, it might be harder to see. Also, things that have a lot of glare content to it can be a problem for some people with low vision. The thing that is really an issue with low vision is that eye conditions vary widely. What might be a problem for one person may not be for another. For example, in the early stages of my blindness, I had low vision, and contrast was an issue for me, and glare content was an issue for me. The print styles really never were for me in particular. And I actually didn't need to magnify things, I just needed to enhance the colors. And the reason for that was that the reason for my vision loss is that I have a degenerative disease of the retinas. My eyes focus perfectly. If it were not for the problem with my retinas, I would have 20/30 vision. So it really kind of depends on what part of the eye is diseased or damaged as to how a person receives vision or doesn't receive vision. For blindness, has a different set of issues. The first one is that you can't really work effectively with a mouse if you're blind. Because the mouse is basically designed to point at something and click it, say, I want that thing there. But the problem is that in order to use the mouse effectively, you need to know where your mouse pointer is, what direction you need to move it to get to what you want to get to, and when you've gotten there. And those are things that are very visual. I've compared it with some people to like trying to walk through a grocery store with a shopping cart blindfolded. You can't do it. There have been all kinds of attempts to try to develop software to give you feedback with a mouse, and my experience with all of that stuff has been that the solution is usually so-so at best. So basically how blind people navigate software is by basically working from the keyboard. And so when you're developing products, particularly desktop applications, you want to make sure that everything that your user needs to get to can be reached with either the tab key or the arrow keys, because that's how a blind person is going to navigate that. The other issue is whether or not your software communicates with the operating system following accessibility standards. And how those standards play out depends on the kind of application it is. There's a different style of programming if you're doing web development, for example, than if you're writing a desktop application. If you're writing a desktop application and it's going to run in Windows, you're going to want to make use of a couple of standards that Microsoft has put out. The first being something called Microsoft Active Accessibility. That's actually an older standard that's kind of being phased out in a lot of respects, although it actually still works. Microsoft Active Accessibility was a standard that was instituted starting with Windows 98, and it essentially provides a means of communicating between the operating system and a screen reader. The standard that has been put in place now is something called UI automation. UI automation basically retained MSAA as a subset of what UI automation does, but UI automation gives you a larger range of different types of controls that you can use, and more flexibility in communicating between the screen reader and the operating system. If you're going to write a Windows application, it would be a good idea to look at Microsoft's website and get familiar with some of the programming practices with UI automation. When a screen reader communicates with either of those standards, it basically works primarily with several pieces of information. First of all, the object name of whatever objects your program uses. Very important that that's a meaningful name, because the screen reader will read it when you actually reach that object, and it will read it verbatim how you named it. So if you give it kind of a nonsensical name, the screen reader is going to give the blind user nonsensical information. The second piece of information that UI automation or MSAA is going to pass back to you is the type of control. Is it a button? Is it a list view? Is it a radio button? Is it a checkbox? Those are the kinds of things it's going to pass back. The third piece of information is the state of the control. Is it, you know, like for example with a checkbox, is it checked, unchecked, or if it's a 3-state, is it checked, unchecked, or partially checked? Those are things that a blind user needs to know. For web-based applications, the programming style is different there for a couple of reasons. First, there's less emphasis on the keyboard with programming for the web other than your important controls. You want to make sure that you can tab to them. But on the web, the arrow keys are really handled by the screen reader rather than by you as the programmer. And the reason for that is because when the web was set up, it was set up to be essentially something to look at for you to be able to point and click. And because of that, Windows web browsers basically don't have a cursor except when you're filling out a form field. And so there's nothing for the arrow keys to manipulate natively with the web browser. And so what the screen readers did was they created something called a virtual buffer, or some call it a reading buffer. But the idea is that it loads the contents of the web page into this block of memory and basically places what they call well-formed XML in the buffer, and that is actually what the screen reader works against. And the screen reader creates something called a virtual cursor that you can move around with the arrow keys and read as if you were in a word processing document. So that is how a blind person would access the web. Now, what kinds of things are important on the web? The biggie is that things are properly tagged. When you're dealing with controls on the web, you want to make sure that your buttons always have meaningful names as part of the tag, because the screen reader needs to be able to read that. So you should never have a button that says something like unlabeled 0. You actually do need to assign those labels, because otherwise somebody using a screen reader will have no idea at all what that button does. Same thing with links. The links should have meaningful names. And some of the practices with naming links that you want to watch out for are things that start with click here or go to. The reason for that is because how a blind person actually accesses those links is that all of the major screen readers will actually have a feature in there where you can list the links and then use something called first letter navigation to move to the link you want. And essentially what first letter navigation says is that if you press the first letter or couple letters of a link or control, it will move the pointer right to that if it's in a list. Well, if everything starts with go to, that kind of subverts that. And so that is kind of a bad programming practice to do that. You want your links to actually have a name that reflects what they do, but you don't want to have something like a go to in there, because everybody understands that a link is going to go to something. And I got to unlock my screen here for a minute. Hold on. Yeah, wouldn't it be? Okay. So I'm just going to kind of try to wing it. The next thing I want to talk about is what kinds of things you should consider in your program design. In modern programming design, there is a concept that we talk about called shift left. What shift left basically says is that if you view your programming effort on a continuum from at the left end starting with an idea to the right end having a fully developed product, you want to consider accessibility close to that left end rather than to the right end. The reason for that is because if you develop something with accessibility in mind from the beginning, it is much less costly to implement accessibility features than it is if you have to try to retrofit it at the end. Now, if you're working with the web, where things can get kind of fancy and sometimes you kind of wonder, well, is this going to really do what it's supposed to do or not? One way that you can basically help yourself out is, as you're developing something, use one of the accessibility checkers. And there's a whole bunch of them out there. If you Google accessibility checker, you'll see a whole list of them. I particularly like one that's put out by a company called DeQue, and that's spelled D-E-Q-U-E. And it's available, well, you can actually find a link to it on their site that will actually take you to the web store for Google Chrome. And the product is called AXE, spelled A-X-E, you know, like the thing you chop wood with. And what it will do is it will install as an extension to Chrome, and you can basically pull your web page up and it will scan what you've developed and compare it against the standards for accessibility and give you a list of problems that it found. Is it bulletproof? No. But what it will do is it will get you past probably, I would guess probably 60 or 70% of the things that cause accessibility issues. It'll get you in the ballpark. The things that it might miss will generally be things that are fairly minor. When you get to a point before you're ready to launch your product, you always want to have a manual review process also. And a manual review process means that somebody who actually uses a screen reader is going to sit down and try it out. I find that usually when you're doing accessibility reviews in a manual process, you always want to do that with one blind person, one-sighted person. The reason for that is because if a screen reader doesn't read something, the screen reader is the only thing that the blind person has to tell them what's there. So if it doesn't read something, as far as they know, it doesn't exist. So you will always want somebody who's sighted and somebody who's blind so that the sighted person can be like, okay, does it show you this? One of the things that you want to be aware of when you're developing design for the web is that there's actually a standard out there called WCAG. It stands for Web Content Accessibility Guidelines. It actually concerns much more than blindness. It concerns a whole range of disabilities, and it would be a good thing to get familiar with that, because non-compliance of that is essentially where a lot of companies are getting sued right now. The website that I mentioned earlier, www.dq.com, actually has a link out there for the WCAG programming standard. So if you're developing something and you want to review those programming standards, you can go out there and follow that link, and it will give you all the do's and don'ts in nauseating detail. What I want to talk about now is actually the different types of technology that are out there for blindness and for low vision. For blindness, generally what is used is something called a screen reading program. A screen reading program is a program that essentially serves as an interface to the operating system. And what it tries to do is it tries to track the focus of the operating system. The focus is basically what the keyboard is pointing towards. And anytime something new gets focused, it's the screen reader's job to read it to you. Now, how it reads it can depend on what you're using for output hardware. A screen reader can either drive a speech-to-text engine like Eloquence, which is a speech package that was written by Nuance, and it essentially just takes textual information, converts it to basically spoken text, and basically sends it out through your sound card. By the way, there is still some older technology that uses a hardware synthesizer, and I actually do still use some of that equipment, where it will just take an ASCII text stream, and through hardware it will convert it to speech and read it. The advantage with the hardware synthesizers is they don't take up any processing time on your computer to generate the speech. The disadvantage to them is they do sound kind of mechanical. So the screen reader is basically just going to tell you where your focus is. The second thing it can tell you is when new text appears on the screen, and the screen reader actually has to make a decision there about whether the new text is actually anything significant that you need to hear or not. And making those decisions is kind of where I get into the game in doing some of the programming that I do, because not everything that appears on the screen is something that's timely or beneficial. And so when that happens, somebody doing development for the screen reader has to figure that stuff out. Most of the time, the manufacturer that makes a screen reader figures that stuff out and sets some general rules for how the screen reader should react to the operating system and to applications in the operating system. The common screen readers that are out there nowadays can range from professional packages that you pay a lot of money for, like JAWS, which happens to be what I'm running on this machine here, or free applications that you can download like NVDA, or built-in applications for reading the screen such as WindowsNarrator. I'm not a big fan of narrator myself. I find that Microsoft is still trying to figure out things that everybody else figured out 20 years ago. For example, one glaring example of that is if you try to download a file while the narrator's running and it puts that progress bar across the screen, narrator will sit there and it will read every percentage as it changes, and it will sit there and it will just chatter endlessly, and it makes it so that it takes a very long time to download a file, where the other screen, the more sophisticated screen readers have actually figured out, no, you don't want to read every percent. Maybe you only want to read in 10 or 20% increments. And usually they actually do that based on time more than by percentage count. And so those are much more efficient in that respect. Magnification programs are something that are used for people who are low vision users. And magnification programs usually have a couple of things that they do. They can, first of all, enlarge things, and you get a great deal of control over how much you enlarge it if you are using an add-on package like Zoom Text. They also can perform something called image smoothing. What image smoothing does is when you increase the size of something, if you don't do image smoothing, you'll hit a point where you'll see the individual pixels that make up the image, and it kind of almost looks like the image is made up of little building blocks. And it's very, very distracting to look at for somebody with low vision, and can actually lead to a lot of frustration. So the better screen readers will try to, or not, I'm sorry, not screen readers, the better magnification programs will try to keep the original shape as it blows it up, and they call that image smoothing. It tends to take a lot of processing power to do that, so if you're going to have a magnification program running on a computer, usually with those things, more memory is better. They actually usually use a lot of memory. For example, for Zoom Text, the minimum memory that you have on a Zoom Text machine is generally 8 gigs. And again, the more memory you throw at it, the better your results. Another thing that magnification programs can do is they can basically allow you to remap colors. So if you have something that's poor contrast, you can actually go in and you can basically reset the colors that the low vision person sees so that it's a higher contrast color. And you can save that on an application by application basis. So if you only have one program that's giving you trouble, you don't need to go in and play with the Windows colors and mess up the whole operating system. You can just take care of the one program that's giving you trouble. Most of the low vision programs like Zoom Text can work from the keyboard or the mouse. The mouse is not as much of a problem for somebody with low vision as it is for somebody who's blind. But the one thing you want to keep in mind with magnification is that the more you blow it up, the smaller the chunk of the screen is that you see. All right, so some of the issues that you run into with technology in general is that, first of all, sometimes you run into programs that don't follow any of the accessibility standards at all. with a screen reader that can result in just silence. A good case in point is something that came down to our manufacturing area to look at. It was a program that generated print labels, and they were trying to set that up, and when somebody who was using JAWS went into the program to look at it, it just said blank. No matter what they did, it said blank. You couldn't move around from field to field. There was no keyboard support for it, but there also was no support through MSAA or UI automation. And apparently what this program was doing is it was just doing direct screen writes, and it was basically programmed to respond to mouse clicks. So you could click in a field where you wanted to type and then type. You know, we would take the information, you click in the next field and you type. That type of a program became completely unusable, and we had to go find something else. So, you know, if you're developing software, you don't want to create a situation where somebody's going to say, okay, we can't use your software, we're going to have to go look at your competitor. You know, one of the things I find a lot with the web is that people will get kind of cute with the web and try to develop their own controls that look kind of pretty, but don't do anything that the screen reader is expecting. So for somebody who's blind, they have no idea how to use the control, and in some cases can't. And unfortunately, sometimes people that are doing the development try to develop their own versions of controls that are already out there. For example, we're having a real problem right now with the ADP site, because they use a type of combo box or a drop down that they've customized, and it essentially when you open it, it puts a little list down at the bottom of the screen. And JAWS doesn't understand that it's supposed to go read that little list down at the bottom of the screen when you open their custom combo. And so I actually had to write a JAWS script to make it go look for that because it wouldn't do it on its own. Had they used a standard combo box like everybody else uses, there wouldn't have been a problem there. So when you're doing development for the web, as much as you can when you're dealing with forms, you want to stick with commonly established controls. Don't try to invent your own, because that will almost always cause accessibility issues. So, I guess at this point I'll throw it open for questions.
So I have some questions. I don't know about the students. I'll defer to any students who want to ask questions. You program, so I'm curious how your screen readers handle things like camel case variables and indentation and stuff like that. Do you find it easy to program?
Not as easy as I would like it. I use a variety of editors to do my programming. In the case of JAWS, I'm using a proprietary scripting language that comes with JAWS. And so for that, I actually use their script editor. And one of the things they do that I hate is they try to actually do the indentation for me, but they usually get it wrong. And so the first time I sit down with their editor, the first thing I try to do is go and internal that stuff off, because I'm as capable of hitting the tab key as the next person. I haven't in recent times had occasion to use a lot of the mainline programming languages, because unfortunately most of what I'm working with is JAWS. So I've kind of gotten to a point where I'm an expert at JAWS, but probably average at most of the other things. Some things I find easier to just go in with Notepad or Notepad++ and do my work in there rather than using their script editor. Different screen readers have different capabilities there. For example, JAWS, they only use their proprietary scripting language, so you have to learn their proprietary scripting language if you want to change the behavior of JAWS at all. For programs like NVDA, or even for magnification programs like ZoomText, those tend to use more of the mainline programming languages like Python or Visual Basic, or there's a whole list of languages that they can use. I think they use Perl. To tell you the truth, one of the bad things about the work that I do right now is because we are a JAWS shop, I've kind of gotten a little bit of tunnel vision there, and I'd actually love to find a good online resource that would teach me how to do Python, because there's a lot that I think I could do with other packages besides JAWS. I mentioned NVDA, which we do use to some extent, but the idea with NVDA is that it does a very good job of following the accessibility standards, and as long as people in doing development have followed those standards, it works very well out of the box, and you don't need to do much with it. And it's really kind of only when you get to the professional level where you start finding NVDA to be less than adequate, and you actually end up spending the big money for a program like JAWS. By the way, just give you an idea of what the prices are like on that stuff. Professional copy of JAWS sells for $1,295, so it's almost as expensive as buying your computer.
So we just bought a copy of JAWS last week, and it was actually $1,650 for us, and that may have been an institutional price. I'm not sure.
Wow. I'm not sure why it would. Well, question on that: did you buy it with the service merchandise agreement? Because that would have pushed the price up.
It could be. I don't remember the details exactly, but I remember the price tag quite easily.
Yeah, for those who don't know what the service merchandise agreement is, essentially what that is that's an agreement that for a fee, you get the next two upgrades without having to shell out any more money. So typically that would they would add another $250 to your price tag, and unfortunately they kind of dollar you to death, because if you need remote access, then they whack another $250 on top of that, and it can get expensive in a hurry. But that is also one of the downsides of the freebie programs like NVDA, is that a lot of the features for doing remote access aren't there unless you buy another add-on package, and the add-on package is not free. So.
Okay, we're about out of time now, and the next class is going to come in here. So I would like to first thank you very much for your talk. And then also ask whether it would be okay if we have further questions, can I collect those questions and email them to you?
Oh, absolutely.
Okay, sensational. So thanks again, and thanks for your